Student Branch AMU, and I welcome you all to this workshop organized by IEEE on the development of APIs and on AWS. We have among us Mr. Omar Raghib, who is 2018 pass out from ZHCET. He then worked on Zomato for a couple of years and is currently SDE2 at Amazon. Omar Bhai, the whole IEEE student branch is honored and happy to have you with us. With that being said, and before any further delay, over to you, Omar Bhai.
Thank you so much. Assalamu alaikum and a very good afternoon, everyone. I am Omar Raghib. As Asmar introduced, I passed from ZHCET in 2018 from computer engineering. I am working as an SE2 at Amazon, and before that, I was working with Zomato. In this series of web development, I decided to take up the topic for API development and AWS because I felt that these are some of the topics that we don't usually touch in our student life, but are very important as professionals. So when I went for giving my interview in Zomato, I wasn't asked about web development, I wasn't asked about app development, I was asked about APIs. And that time I realized, okay, this is something that we miss during the college days, and that is something that a software developer does every day in his life. And AWS is something that is broadly used these days and is hardly discussed in college. So being at Amazon, I decided to just give a brief introduction so that those of you who are interested can look forward to that topic as well. So let's start. Brief overview of the topic of the talk. We'll be starting with APIs. What are APIs, different types of APIs, and one practical example. Going forward, we'll work with AWS. What is AWS? A brief history and basic high-level overview of its services and products. Lastly, we'll have question answers. Wherein first, I would like you all to ask questions related to the talk. Any queries you have, anything that could be improved, that would have been done better, apart from my photo in the poster, which I only provided. So, and after that, lastly, we'll have Q&A regarding career interviews or any other question that you might have. Cool. So starting with APIs, I think instead of going with the definitions, let's first drive an analogy to help you understand better. So suppose you go to a restaurant, right? When you've gone to a restaurant, you're a customer. And what you have gone for to the restaurant, what is the resource that you want from restaurant? That would be food. And who provides that resource to you in the restaurant? That would be the kitchen, right? So you as a consumer go to a restaurant to get food, which is provided by the kitchen. So do you directly go to the kitchen and ask for the service? That is the food that you need? No, right? No. That is not the way how you do it. What you do is you tell the waiter that you want the food. The waiter takes your order and then goes to the kitchen and gives your order for the food to be prepared. Once the food is prepared, they give it to the waiter and the waiter gives it back to the customer. In this scenario, the waiter is our API. So there are certain subtle things that should be noticed here. Is that one, once you go to a restaurant, you cannot just order anything. You have to order things that are present within its menu, right? That can be called a protocol, that you have to follow a protocol. You cannot go to KFC and ask for masala dosa. You have to ask things that are present in the menu. So you have to follow certain protocols, right? Second, the kitchen is agnostic of what the customer is asking for. The kitchen only knows what the waiter serves it. So suppose at KFC, you go and you order an 8-piece bucket, right? The waiter will take order from you in the form of 8-piece bucket. The waiter will convey to the kitchen that item number 4, which is 8-piece bucket for the kitchen, is to be prepared, and its quantity. So the way waiter communicates with kitchen is different from the way waiter communicates with the customer. But the customer does not know this. For you, it is the easiest way, the way you understand, you communicate to the waiter. And for the kitchen also, the waiter communicates in a language or in subtle synonyms that the kitchen understands. And this waiter, what waiter is doing in a restaurant is very similar to what an API does in the software development environment. Keeping this in mind, if we go and define formally, API stands for Application Programming Interface. Application in programming interface is nothing but a software interface that allows two applications to interact with each other easily. Going into detail, APIs are basically documented way of telling the outside world how they can communicate with your software, right? Suppose you wrote a very good code and it is something entirely new that sorts a given array, right? You take an input as an array and you sort it. And this is something the world has never seen before. The world never understands it. They don't know how it is done. They just understand that if they give you an array, they can get a sorted version of it. And that is something useful for them, this functionality. Now, how do you expose this to the outside world? You don't want them to know the code. You don't want them to go into the nitty-gritties of the implementation, because that might be too overwhelming for someone or too much work, right? Including in the entire code. What you will do is you will document an API and you will say, okay, you know what? I have prepared a software that can give you a sorted list if you give me an unsorted list. The name of my software is sort, and what you need to do in order to use my functionality is to call this sort API with your array, and in response, I will give you the same array in a sorted fashion. This you have documented. So any person who needs a sorted array within his program can call your sort API, just give his array as an input, take the sorted array as an output, and continue with his work, not knowing how you implemented it. Right? This is a great advantage. I don't need to know what's going inside, what is happening. I don't need to implement it. I just know in my human readable format how I can interact with the particular piece of code that you have written. This is a very basic example of an API wherein a piece of software code is exposed as a function. As we go higher up into productionized versions, this gets more decent and follows certain rules. Right? So APIs are of various kinds, and the functionalities of API, one of the major functionalities of API, just as we discussed in the restaurant example, right? You don't know what is going on in the kitchen. You just ask the waiter to give you your order. The waiter then tells the kitchen prepares your food. You don't know how. That is separated from you. Then the waiter gets the order and waiter returns it to you. Similarly, the APIs connect with the backend database, you can say, which is hidden from the end user that is accessing the data. For example, we have browser APIs. A lot of browsers you must have seen when you open a browser, you get a pop-up that says, allow this website to access your location. Right? How does an application access your location? What that application does is, it asks your browser that I want the location of this particular person. This is the API that the browser has exposed, a location API. That application does not go into the working of all these, how the browser gets the data. It just asks the browser using its API that I want the location of this user. What browser in turn does is, it asks the OS API, what is the location of this user? Because location is not stored at a browser level. Location is stored at an OS level, right? But this all is not shown to the consumer. The application, the consumer will ask the website will ask browser, the browser will in turn ask your OS. The OS API will return your location to the browser API will return your location to the particular application, asking the permission, and then the application will make use of your location and move forward. So what would have been a major task for the application of determining your location is made very easy by it calling, when it makes use of the API, location API, suggested by the browser. It just have to write one line of code, get location using the browser, and it will get the location. So now let's talk about what are the types of APIs. APIs can be of many different types depending upon the categorization we are doing. And there are a lot of categorizations that can be done. We'll discuss two major categorization here. The first categorization is based on access, how you are accessing the API, who can access the APIs. Based on access, there are three kinds of APIs. First are the internal APIs. Internal APIs refer to the sets of APIs which can be used within a team or in organizations which have restricted access within a certain controlled group. External APIs are those APIs that are open to all. Anyone can access these APIs, right? These are open source APIs. Partner APIs are those APIs which are created within an organization or a team, and they can only be shared with certain end consumers based on the contract of the organizations. Let's say Google Maps, right? Google Maps API that is owned by Google. They decide that they will share their API. They are not open sourcing it, but they will share their Maps API with Uber. So this is a partner API. They have partnered it. They will tell Uber to pay certain amount per API call, and they will share their API with Uber or Zomato or Swiggy, right? So these are called partner APIs. Next categorization, that is more popular categorization, is based on the architectural style. Based on architectural style, there can be several types of APIs, most famous of which are the REST APIs that we'll be discussing in this talk further on. Then comes SOAP API, GraphQL APIs. GraphQL was developed by Facebook. It was initially an internal API in 2012. Then it got transformed to a partner API around 2014, and then it became an external or public API in 2015. Similarly, gRPC was developed by Google. It was initially an internal API in 2010 and became a public API or external API in 2014. The most important of these APIs and the most widely used is the REST API. The REST stands for Representational State Transfer. What this essentially means is that any API that follows 5 basic constraints, right, that we'll be discussing, is called a REST API. It is a standard. It is not a protocol, just a standard. Any API in any language following any tech stack which just satisfy these 5 conditions are called REST APIs. The benefit of using REST APIs is that they are a standard. They have been standardized in the industry. So if I am one organization and I plan to expose my API and I say this is a REST API, any other organization planning to use an API will know, okay, this is a REST API, so it must be following certain standard rules. And because I know these standard rules and I use it for accessing other APIs within my organization, I can use this API as well. So the interconnectivity is highly increased using standardization, for which the REST is the most adopted version of APIs. So there are 5 basic constraints for an API to be called a REST API. The first is client-server decoupling. That is to say that within your API, there should be a client that should request the resource, and there should be a server that will give you the response. And both of these clients and servers should be decoupled, right? Secondly, REST APIs are stateless. Stateless means that they don't know the previous state of your data. Meaning to say that all the information that is needed for a particular request will be sent in that request, and the server will not hold any previous state of the request. So all the data that you need, any response you need, you will send the data within the same request and receive the response. You won't assume that there is some existing data within the server that may know something about the request. Thirdly, it's cachable. This is very important to increase. Am I audible?
Yes, by you're audible.
Okay. Sorry, I thought my earphone got disconnected. Yeah. So next we have Cashable. So Cashable is the property that makes REST very performance intensive. It gives you one of the best performances in all the APIs. The reason being that the primary requirement for an API to be REST is that it should be cacheable, such that the cache can be put near the server or the client or in the middle, depending upon the use case, but it should support caching. That is a requirement for this, right? Next, we have uniform interface, and some of these definitions might sound a little bit overwhelming, but eventually, as we move forward and as we do more practicals, you will get to know, get a better understanding of these. Okay. Next, we have uniform interface. Uniform interface means suppose there is a mailbox outside your house, right? Anytime you need your mail, you need to go to the mailbox and you will get that mail. That is uniform. Similarly, for APIs, there has to be a uniform interface. That is, there has to be a uniform identifier on which every time I go, I'll get this API. Just like in the case of websites, right? If you go to google.com, Google should open. If you go to amazon.com, Amazon's website should open. Similarly, for APIs, if you go to a particular endpoint in an API, that API should get hit every time. Lastly, we have layered system. Layered system means that even if the API is layered, each layer has knowledge only of the layer preceding it, not the layer afterwards. For example, the location example we took initially. There is an application, there is a website that wants to access your location. For that application, only the location API of the browser is visible, and it will only call that browser API for location. It does not care how the browser gets the location, what is going on behind the scenes for that. It just has the knowledge of the browser API. The browser API for location has knowledge only of your OS API of the location, right? So if you're opening it in Chrome, the application will call the location API of the Chrome. Chrome will call the location API of your OS, that may be Mac, Windows, or Linux, and then the OS will return the location and to the browser, and the browser will return the location to the application. Each layer has knowledge only of the layer afterwards it, not succeeding layers. Another important concept, this is asked several times in the interviews as well. This is there for DBs as well, for APIs as well, for any architectural update you do, is CRUD. You should have working knowledge of CRUD in all the domains, may it be DB or API. CRUD stands for create, read, update, and delete, right? So if you make an API, right, or if you create a DB, how would you create entries into it? How would you read entries from it? How would you update entries into it? And how would you delete entries from it? Right? So SQL equivalent, if someone has worked on SQL, for CRUD, for create, we'll have insert. So suppose we want to create an entry into a DB. We use insert, right? Insert star into this or whatever it is. Then for read, we have select star from this. We write those queries accordingly. Update and delete are same for SQL while accessing a database. For REST, which mostly works on HTTP, the equivalence for these would be if you need to create something, right? If you need to create an entry, you would write post. The create would be the post call. It would be a post request. We'll take an example after this, which will help you understand better. But remember this for now. Create is a post request. Read is a get request. Update is a put or a patch request. And delete is a delete request. Right? So when you need to create something, when you need to add an entry, you send a post request. When you need to read something, you send a get request. When you need to modify a data, you put a put or a patch request. And when you need to delete an entry, you send a delete request. Let's take an example. Suppose you own an ice cream shop, right? And now what you want to do is that you want to create a web application which shows all the flavors in stock in your ice cream shop. What you also want to show, what you also want is that the workers should be able to update these flavors as and when they go out of stock and they come in stock. Okay. So what we want to create a web application which displays all the flavors in stock, and we need the functionality to update them as well. How do we do this? So for this, your browser in which you create the application will be your client. I think my presentation is not working. Is my presentation working? Can you see the API page?
Yes, we can see that.
Okay, then there must be some issue with it. Just a second. Okay, mine is stuck. Okay, can you guys see it now?
No, right now we cannot see it.
Just a second.
Yes, now it is visible.
Cool. Okay, so now what we do is we have our browser as the client, and we say that in some cloud there is this database that stores these flavors, right? That stores our entire data. Now what we'll do is we'll create a REST API which sends a request to the server, which may be in a cloud or which may be hosted on premise, wherever the data is stored, and we get the response accordingly. So suppose we want to know all the flavors which are in stock, we'll send a request saying, hey, tell me all those flavors that are in stock. The server will respond with all the flavors those are in stock. When we want to update, let's say, a flavor, we'll send a request saying, okay, update this flavor, update its stock or whether it's gone out of stock. And the server will send us a response whether it has been updated or not. Now, in order for the client to communicate with the server, there needs to be an endpoint, right? Just like in case of websites, you have a URL. Suppose you want to reach Google server, you will type google.com. You would want to reach Amazon server, you will write amazon.com. And then through a series of steps, it will know that when you are accessing amazon.com, a particular page has to be hit within the Amazon server, and it will give you the response. Similarly, APIs have endpoint. An API endpoint for our ice cream use case can be something like this: icecream.com/API, telling the users that this endpoint is for an API /flavors to get the flavors, right? This is just an example. Endpoint can be of several different types. Now, how will a request and response look? Let's just have a look at it. For each request, there will be a header. Header will have some data related to authentication, right? And other data that is a little high level for introductory courses. This is just for your knowledge that there will be a header with some auth data and other stuff. Then there will be this operation. What is the operation that you're going to perform? Whether it's a get operation, whether it's a put operation, whether it's a post operation, whether it's a delete operation, right? Whether it's what among crud is this, the ones we just discussed. Then it will have the endpoint where this request has to go. And then there are the parameters or the body of the request. We'll look at an example and we'll understand this better. But at a high level, this is what a request contains, right? A response will be a JSON object. Now, those of you who are unfamiliar with JSON, JSON stands for JavaScript Object Notation and is the most widely used format for representing data in software engineering. So, just to give you a brief overview, when you want to represent a data, right, there are several ways to do it. One is CSV, that we call comma separated values. So you have values like 11, 12, 13, or something like Umar, comma, Asmar, comma, names going on like that, right? So that is one format. And if you say that my data is in CSV format, the person reading it will know that when I have to pick up the elements, I know they will be comma separated, so I can delimit them at comma and read the elements. Similarly, what JSON stands for is, at a high level, you can say JSON is a data format in which data is represented in a form of key value pairs, right? So if I have to represent myself as a JSON, let's say, I'll have a key name and its value will be Umar, right? Then I may have a key age and the value will be 26. Location, Aligarh. Like that, key value based pair representation of data is called JSON representation. Most of the requests and responses in REST APIs happen in JSON format only. Okay, now let's take an example where you want to get the flavors in stock, right? All the flavors that are in stock. How would you do that? How would the request and response for that look like? For the request, headers will remain as it is. We are not touching that. For the operation, we will have get. Why? Because we want to read the data. What all are the flavors that are in stock, right? The endpoint would be same after API, like icecream.com/API/flavors, because you want to get the flavors. Once this request goes to the server will read, okay, this is a get request, and what does it want to get? The flavors. The server will then return a response which may look something like this: an ID for a flavor. So ID 0 would be, let's say, vanilla, and ID 1 would be Belgian chocolate. So now what will be displayed is that there are two flavors in stock. One is vanilla and one is Belgian chocolate, right? Now, let us say that your Belgian chocolate went out of stock and another ice cream flavor came in stock. What you want to do is that you want to replace this particular element, ID1 and flavor Belgian chocolate, with the new flavor that has come in. In order to do that, you will send a request, which will be a put request. Remember, put was for update, create was post, read was get, update was put, and delete was delete. So here we need to update this, that Belgian chocolate flavor needs to be replaced or updated with strawberry flavor. So what we'll do is we send in a request with put as the operator. The endpoint will be /flavors/1, indicating that we need to update this endpoint, flavors followed by the ID. And the body will contain the flavor that is to be updated, right? The parameters. And the parameter would be flavor and strawberry. Another way of implementing this could have been the endpoint should have been left as flavors only. And within the body, we could have given ID as well as the flavor. And this entirely depends upon how the developer is developing an API. So if you develop an API in future, which I hope most of you will be doing, you will document each and everything. So you will document that if you want to get the flavors, you have to send in a request wherein the endpoint will be flavors. You don't need to send anything in the body, and this response with all the flavors in stock will be returned to you. You will also document this, that whenever you need to update something, the endpoint will change to flavor/ID for the ID that need to be updated. And within the body, the flavor has to be passed. If you decide to go other way around, you will document that in order to update, the endpoint will remain the same, but the ID has to be provided. Suppose we needed to add a new entry, right? We got a new stock, let's say, something like butterscotch. In that case, the operation would have been post, the endpoint would have been flavors, and the body would have contained ID 2 and flavors butterscotch. And once we did that, and after that we did this get operation, then we would have got ID 0 vanilla, ID 1 strawberry because this had been updated, and ID 2 butterscotch. Right? The particular way in which you implement is left up to the developer as long as those 5 constraints are being fulfilled. The important thing that a developer should always keep in mind is that whatever you do should be well documented so that the external consumers consuming your API can clearly understand and use your API accordingly. Going forward, let's take a look at AWS. For API portion, I have just given a high-level overview of it. We can go in depth for each type, right? What is RPC, what is OpenQL, what is GraphQL, and what are the best practices. But because this is just an introductory session, I have kept it rather simple so that just you guys just get an idea of what an API is, so that tomorrow when we do a practical implementation, you just know the basic things, and advanced APIs can be picked up maybe in other session someday. Now coming to the basics of Amazon, AWS, which is Amazon Web Services. AWS has exploded so much today that if you want to give a one-line definition for it, it is quite difficult. The best way to understand it is to understand the history behind AWS, right? What brought AWS into picture, how it started, how it got created. And once we know the events, I think we'll appreciate what AWS is, and it will help us in understanding it better. So first we'll start with the history of AWS, how AWS came into picture, right? Just a second. Yeah. So this was back in late 90s when Amazon was just a startup, but growing at a rapid pace, right? It started with books, then groceries, then everything was being sold at Amazon. Amazon was growing faster than it could scale, right? So the producers in Amazon were growing at a rapid pace, and the tech stack that they had was not able to match the speed at which the business was growing. This got Bezos a bit worried, and he told the team to start looking for ways in which we can scale the tech as the business is scaling, right, at the same pace. And this was more fastened by the delay in the launch of Merchant.com in 2000. So Merchant.com was an idea that Bezos had, wherein he wanted the retailers such as Marks and Spencer's, right, H&M or Zara these days, to sell their products on Amazon Marketplace when they create their web solutions on top of Amazon solution, right? So that if someone visits a Marks and Spencer's website, they can add things on that website just as they add things in Amazon cart. So eventually things would be added in Amazon's cart and order would be placed at Amazon, just that the website would be Marks and Spencer's. That was his vision for Merchant.com. But because the tech in Amazon at that time was so intermingled, this could not be done on the desired date. Then, under Andy Jassy, Amazon formed a specialized team to recognize where were they lagging, why was there this lag in software development that it was not able to scale with the speed at which business was growing. And what they realized was, one, there was a lot of coupling within the system. So they decided that they will move to API-based architecture or microservice architecture instead of a monolith, right? Instead of just lines of code being executed, they said we will separate these all codes and they will communicate to each other via APIs, right? And secondly, what they noticed was that each team was writing code for a particular functionality by its own. So they were having a particular implementation of a functionality using different techniques, maybe different tech stacks. Each team or each org had a different implementation of the same functionality. Now, this is where they saw a chance that if the functionality is same, what we can do is we can have Amazon-wide standardization for that particular functionality, and each team within Amazon should use that standardized version using API calls. Right? This is what gave birth to the idea of AWS as we know it today. So in 2003, there was a paper presented by two of Amazon employees, Chris and Benjamin, wherein they said that the common functionalities within Amazon should be taken out, standardized, and put in as an API. And all the teams within Amazon should be using those services. These standardized services or functionalities should follow a certain bar, right? They should be secure, they should be scalable, their changes should be agnostic of outside consumers, and a list of things. But this was the idea, which laid the foundation of AWS. And in 2004, AWS released its first service or first functionality, which is called SQS or Simple Queue Service. Now, SQS is a concept that requires a bit more discussion, but it is quite an advanced topic, so I won't go into the details. At a high level, you can think it of as a functionality wherein people put their data to be processed, and the consumers read their data from the same part of code or from the same system, that is queue. This is widely used concept, and initially what was said that each team within Amazon had its own implementation of queues. What Amazon did was that it separated the queue, it standardized it, it created the best queue service that could have been created, and told all the teams within Amazon to use this queue via API calls if they wanted to use a queue in their system. Now, how this helped was that whenever this process was fastened, right? Whenever a new functionality needed to be added, the team did not have to implement the entire queue on their own. They just need to do an API call. The queue service, SQS team, would know, okay, now more and more teams are using me, so I need to scale further. They created SQS in such a way that it could be scaled easily. They scaled it, and they were able to increase their efficiency by more than 20% with just this one functionality. Following the success of SQS, in 2006, AWS was officially launched. What AWS did was that it provided infrastructure as a service, right? What they did was everything that was needed to run a company, right, to run a business, they decoupled it from within the code, they standardized it, and they told anyone who needs to use this service, who needs to use this infrastructure, can contact us using API calls, right? So suppose you wanted a queue, you did not have to put in a queue, you did not have to write a code for it, you can just do an API call. Suppose you wanted a virtual machine, right? You wanted a computer for a system, you want to build a website, now you want to host it somewhere, you want your pages to reside somewhere, you don't have to buy a server. What you can do is you can tell Amazon, hey, I want to host a website, so I want a server for it. Amazon will say, okay, what kind of server do you want? I'll say I want a small one. Since my business is small, Amazon will say, here is your server, you can get started. So they provided infrastructure as a service. And when they launched in 2006 with the limited amounts of services and products, within 1 year, more than 180,000 developers were using AWS. So they stopped buying servers from outside. They stopped writing their own code for functionalities. Those were redundant, and they used the Amazon standards. By 2010, they moved entire Amazon on AWS. So initially, Amazon used to use the database of Oracle, right? And some other, maybe some products of other companies like SAP, right? For HR solutions. By 2010, they have migrated everything to AWS. They wanted to use a database, they provided database as a service within AWS. They wanted to use HR solutions, they provided HR solutions as a service within AWS. Right? This, since Amazon, which was growing at a rapid pace at that time, adapted to AWS completely, this promoted more and more developers to use this. It also gave the flexibility of a lot of upcoming startups to use this. And this was particularly advertised in the Silicon Valley, which adopted it at a rapid pace. Why? Because earlier, if I had to start a startup, the initial cost, the procurement cost of the systems, the servers, the databases was too high. Right? I had to procure physical systems in order to my system to run. And if my startup failed, all that money will go in vain. Right? What will I do with the server when my startup has shut down? And in order to procure those servers, I need huge amount of sums. What Amazon did was they said, okay, you don't need to buy any servers, you don't need to buy anything. We have servers for you. You just take this API call, you call our servers, you use it as a service, and we will charge you on hourly basis. Right? How much you are using, you pay on the go only for that much amount. And this was an idea that took entire Silicon Valley by surprise. They were like, wow, this is something that all the new startups could use, because then your initial cost reduced humongously, right? You pay as you use, and you get the best from Amazon. You're getting the best standardized DB, you're getting the best standardized infrastructure, and you are not paying the entire amount. You're paying on the go how much you're using. So if, let's say, after 1 month, my startup shuts down, I'll pay only for the usage of 1 month, and then I'll stop paying, right? So this increased the adoption of AWS to next level. And in 2012, they had first Amazon reInvent conference. So Amazon reInvent conference is a conference where developers from around the world gather together in Las Vegas, and AWS releases all the new features and functionalities that they have added in that particular year to AWS. And it is one of the largest, the largest developer conference that happens on our planet. They also have an after party that is considered to be the best tech after party that happens as of today. Right, and from 2012, every year this has been hosted. In the past 2 years, it was hosted virtually from Las Vegas only. Otherwise, it's in person. Right. In 2013, because this was adopted by a lot of developers, Amazon started provisioning certificate courses for computer engineers where you could be AWS certified. And even today, AWS certification has a lot of credibility to it. And if you are AWS certified, there are a lot of job opportunities, high paying ones, that open up for you. Right? In 2015, AWS was declared profitable, wherein its revenue in Q3 surpassed $2.1 billion. Right? So 2015, it became profitable. And it was in 2016 that AWS was first time mentioned in the annual business report of Amazon. And because it was such a profitable business, it got heads turning around in the entire tech space, and other companies like IBM, Google, who was working on it, but not at such a rapid phase, they fast forwarded their approach towards cloud computing and providing those as a service. One of the reasons that AWS is the leader in this market is because of this early start, and all the other players like Google, Microsoft, IBM coming later on, only realizing the potential once all these numbers were released. AWS is by far the most profitable business for Amazon. Last year, its revenue crossed $62 billion. The overall Amazon revenue was over $400 billion, but the AWS is such a profitable business that out of the 62 billion, around 35 billion was net profit. So it is by far the most profitable business for Amazon, which earns Amazon more money than its actual e-commerce business. This was so popular that when Jeff Bezos had to step down, Andy Jassy, who was the CEO of AWS, became the CEO of Amazon because he introduced the most profitable business to Amazon. AWS is used by 80% of the Fortune 500 companies. Even the competitors of Amazon, like Flipkart in India, right? They use AWS for their systems. Competitors among themselves, like Zomato and Swiggy, they use AWS. So if you go to a startup, if you go to any company that is scaling at a rapid pace, there is a high probability that it will be using AWS. Microsoft Azure is starting to become popular, but still its market share is only 19%. So even if it works at this pace at which it's going, it will take several years to come close to AWS. And that is why learning AWS and having a basic knowledge of it comes handy once you go professionally out there. So now coming to a formal definition of AWS, we can define AWS as a comprehensive, evolving cloud computing platform, which is provided by Amazon. That is a mixture of three things: infrastructure as a service, platform as a service, and software as a service. Now, what do we mean by these is, let's start from the bottommost. Software as a service. Software as a service is provided to the end user, like Microsoft Office, right? It is a software that is provided you as a service. It is you who add data to it, right? Microsoft PowerPoint. I am adding this data. I've created this presentation using a software that was provided as a service by Google, Microsoft, Amazon, anyone to me, right? So AWS has several components that it provides as a service, complete softwares that it provides as a service. And the users of SaaS are usually the end users, like someone who has to prepare a report, a presentation, a slide. Then lower in the hierarchy, we have platform as a service. Platform as a service is mostly used by developers, wherein you are provided the entire platform except for the application and the data. What that means is that you will be given everything, starting from the database, maybe to the networking calls, to the load balancing, everything you need, the platform, the OS you need, you will be provided with that. The software that has to be written by the developer. So you don't need to install an OS, you don't need to install dependencies within a system. You will be provided a system with predefined OS, software, dependencies, everything. But the code that has to be written by the developer, right? So you are given a platform as a service. You don't have to worry about any of those things, about patching the OS, about anything. You just have to worry about writing your code, right? Then third is infrastructure as a service. Infrastructure as a service means that Amazon or AWS will provide you with basic infrastructure. That is, they will give you a machine, they will give you a DP, they will give you the infrastructure, the hardware that you would have procured from the market as a service. So you don't have to go to the market and procure a server and maybe ask for a database from someone else. Everything integrated will be given to you, but those will be raw. Any OS that you want to install, you will have to install on that. Any dependency, any patching, that will have to be done by you, right? So the basic tier of the service is infrastructure as a service, wherein all the hardware that you would have procured from the market is provided you as a service and charged on an hourly basis. The next tier is platform as a service, wherein on top of the infrastructure that is provided to you as a service, the software, basic software, is provided to you along with that hardware, like OS, right? Like any dependencies, any patching systems is provided to you as a service. And the top layer, entire thing is software as a service, where you get everything and you just have to put in the data, right? The most common one used by developers is platform as a service, right? If a startup is starting and is at its very initial stages and don't want to go into the nitty-gritties of small software handling, patching, etc., they prefer to use platform as a service. But if there is a tech startup that wants more tight control over basic software components, then they choose to go with infrastructure as a service, where they don't procure any hardware from outside. They take in infrastructure from Amazon and then they add their software over the infrastructure provided by AWS. So AWS is basically segregated into different configurable services, right? There is no one service that can be called AWS. There are three categorizations, like we discussed: infrastructure, platform, and software as a service. Within these categorization, there are many services that Amazon offers. More than 100 services are offered currently by Amazon, which is far more than any of its competitor, Azure or Google Cloud. Right? They have services in the range of 40s to 50s. Amazon offers more than 100 services there. We will look at some of these services in the next slide. Going into detail on all of these services is not possible, I think, even for a lot of advanced people, because you just have to pick and choose the service that you need to use based on your requirement, right? A good concept, very concept to the core of AWS is regions and availability zones. So what AWS boasts about is that it is highly available, right? It is more secure. It will make your data more readily available than you can by procuring your own hardware, right? So when it started as a service, as a basic service with the business use case of that you don't have to buy your own hardware, you can procure it from us. But with time, they have evolved to a level where they say, even if you are able to buy your own hardware, we provide you with better hardware than you can set up on your own. And a major point, that selling point for those, is the availability. So Amazon has 26 regions and 84 availability zones. What this means is that the AWS servers are put in 26 regions currently. Those are represented by the blue dots in the map, spread across the globe, right? So what these regions are nothing but a group of availability zones. View it like this. There is one region, and within a region, there are at least 2 availability zones. There can be more than 2. So a region, suppose, is Mumbai. Within Mumbai, what they do is they make one availability zone, let's say as Kolaba in South Bombay, and other availability zone may be Malad, and third availability zone may be a third area. And all these availability zones are connected with low latency wire. They are about 60 miles away from each other. Each availability zone is nothing but a room full of servers, right? You'll go there, you will see rooms with a lot of computers set there. The advantage of this is that the data is replicated across each availability zone if it is configured in such a way. What is the benefit of this is that if something happens to one availability zone, right? There is a fire in one of the availability zone, one of the computer catches fire, and entire availability zone, entire data center that was there, it goes down. Then also your data is present at 2 other availability zones within the same region, right? Maybe near microsecond data would have been lost, that might not have been transported to the other availability zone, but major chunk of your data is safe. And this is something that you cannot do, is difficult to do even if you procure your own hardware, right? Then apart from, each region has 2 or more availability zone, which provide high reliability over the data, so that even if one availability zone goes down, then your data will be at least 2 or 3 other availability zones. Availability zone are within the same region, and then you have regions across the globe. Different regions. You have regions in America, Australia, Japan, China, everywhere, right? In South America also, in Africa as well. And there are 8 other availability zones. Those are coming up, represented by the red dot. Regions, Amazon has 26 regions. Next, that is Microsoft Azure, has close to 11 or 12 regions. Why this is important is that suppose you pick a region that is far away from you. Sitting in India, you pick a region in North America, right? US East 1. Your latency will be higher when your data is being stored in a region in US. Both, the difference may be in microseconds or milliseconds, but when you're working at scale, right, those each microsecond counts. So if I have a region, if I have my data center within India, I get response in, let's say, 2 microseconds. When I have it in USA, I get in 2.8 microseconds. It's 0.8 microseconds, but it matters a lot when you're doing development. Because AWS has this vast variety of regions, a lot of developers prefer it because of low latency. Right? The concept of availability zones is similar in other cloud providers as well, right? Azure and Google Cloud. They also replicate the data. They also provide you high availability based on availability zones. But because their regions are less, their availability zones are less, the options you have are minimal currently. Right? So whenever you start building a service, the first thing you have to pick is the region where you want to take the service from within Amazon, within AWS. Next, you select anything else. Now, AWS, as we discussed earlier, provide over 100 services, right? And going into the detail for each is not possible, but some of the most important services that AWS provide include EC2, which is Elastic Cloud Compute Cloud, which is used for computation purposes, right? These are virtual servers that are provided by AWS to you. For storage, Amazon provides with S3, that is Simple Storage Service, and Elastic Block Storage, EBS. Storage means that wherever you have to store your code within AWS, right? You take their machine, you compute it within AWS, but where do you store your results? Where do you store your, let's say, code, your README files, and anything? For that, Amazon provides S3, Simple Storage Service, in which it stores everything as an object. Then for database, Amazon has support for almost all the SQL databases like MySQL, PostgreSQL, and Oracle. For NoSQL databases, Amazon uses DynamoDB, which is a proprietary database of AWS. Then for management of AWS, you have CloudFormation, wherein you can dynamically bring up a service, drop a service, and manage your entire system. For monitoring, you have CloudWatch, which has very good graphs, which you can use to monitor your system, whether your system health, your system status, number of requests coming in, going out, etc. For big data, this was integrated, I think, in 2018. Amazon has several features like Elastic MapReduce, Glue, Kinesis, Elasticsearch, Athena, and it's a long list. A lot of big data companies are using AWS for their purposes. In terms of AI, this was included in 2019 within AWS. The very popular Alexa, this is also provided as a service, some of the APIs of Alexa. And apart from that, we have Lex and Polly, which are used by artificial intelligence developers. For messages and notifications, we have Simple Queue service. That was the first service to be launched by Amazon. And for notification, we have Simple Notification Service, or SNS. Similarly, for AR and VR, which are very new domain, Amazon has integrated Sumerian and is working on other tools as well. And apart from this, Amazon provides a lot of developer tools like API Gateway, which we will be discussing tomorrow, how we use that, and Elastic Transcoder, which is for transcoding packaged media services. So this is just a high-level overview. If you go to depth of Amazon Web Services, it is too deep. I would recommend you guys to just go to AWS and scroll onto their service pages. There are a lot of services will open, but for starting, I think these services, along with some of the things like Lambda, is good for learning as a starter. But as system gets more sophisticated, more and more services keep coming in. That we can discuss sometime, maybe in a more advanced talk. That is all from my end. Thank you so much. And we are open to questions now.
I request everyone to ask questions if they have any.
Assalamu alaikum, Omar bhai.
Walaikum assalam.
Actually, I have a question. Since I am learning data science right now, my question is, what is the significance of API and AWS in data science jobs?
Okay, so API in general has a lot of significance, not specifically to data science, but software development only, right? So in data science as well, suppose you want to use a model, right? Let's say Alexa model, you're working on voice recognition. You want to use some predefined model that has the capabilities wherein you can just give your input for the voice recognition that you want to do, and you want the output, and then you want to write over it. Then you can use the Alexa provided by Alexa APIs provided by Amazon Web Services. Apart from that, as I mentioned, there is Lex and Poly. Lex is for voice and text chatbot technologies, and Poly is for text to speech translation. So you don't have to write your entire code for text to speech transition. What you can do is you can just give the text to Poly, call an API using the text, and Poly will return the speech version of it. And you can select various accents, whether it should be a male voice, female voice. You can integrate to your system, and then whatever you want to do, you can develop over it. Also, most of the data science deals with huge amounts of data, right? Because it's all upon how good you train your model. If you're using your own model, then Elastic MapReduce and Kinesis provide you with probably the best hardware acceleration that is required for processing that kind of data. The specific service that you will use depends upon the use case within data science that you are solving, whether it's it's voice recognition, image recognition, it's data intensive or it's latency intensive. But yeah, Amazon has options for each of those depending upon the use case.
Okay, thank you.
Answers.
Assalamualaikum, bhai. You mentioned that data is stored in 2 or 3 places in AWS to be used as backup. So my question is that, but would that not be a compromise on the security of that data?
The data is stored at 2 or 3 places.
Yes.
No, it's not at 2 or 3 places. Okay, in the availability zones. No, so the way it works is these are just physical locations, right? Physical stores, different availability zones. Even if a person enters a physical zone and it sees servers, those servers are internally encrypted. If a person goes and steals those servers, he cannot access the data within it. Right? The data is encrypted. All of security is one of the more, let's say, pronounced selling point of AWS. Right? Everything is SSL certified, and then there are 3 protocols to be followed before the data can be stored in Amazon. So there is. Yeah. So there is no as such risk of data being stolen if a physical store is compromised. Like if an availability zone is compromised and someone physically stores, they cannot decrypt that data. That is not possible. The benefit of doing it, the reason for doing it is if it catches fire or anything, then the data should not get lost. Stealing is not the concern because decrypting will take so much time that the data will render irrelevant.
Does anyone have any other question? I guess not. So thank you so much, Omar Bhai, for taking time out of your busy schedule and agreeing for organizing the workshop. The session was definitely informative, and I hope that all the participants have found it valuable as well. I would like to remind the participants that this is a 2-day workshop, and today was just the first session. I encourage everyone to participate in the second round of the workshop as well, which is scheduled for tomorrow. I would again like to thank Omar Bhai, and with that being said, we are signing off. Thank you so much for joining.
Thank you so much, everyone. Good day.